again for the last presentation for today. So will be done by Victoria Cherkalova with high availability on in Linux, Pacemakers problems, and what do we do about them. You're welcome.
Okay. Hi, everybody. My name is Victoria Cherkalova. I'm from Dell EMC, and today I'll talk about high availability clusters, cluster managers, and I will talk about Pacemaker, who is a cluster manager, a brief overview on what it does and its main functionality. Then we will go over the issues we've encountered and how we solve them in Dell EMC. So, very brief information about Pacemaker. It has been around since 2004. It's mainly maintained by Red Hat and NCUs. It has paid support from Novell, and it's distributed under GPL version 2 license. Okay. Note, Pacemaker is a cluster manager, but it's not a container cluster manager. Who here worked with clusters? Anywhere? Okay. And of those of you who worked with Docker containers in clusters? Okay, this is not about that. Yeah, Pacemaker appeared a bit before all containers became popular, and it works with Linux processes. So it makes sure that Linux processes are highly available for your system. For those who didn't work with cluster, there were some. What is cluster? In our case, it is a set of nodes, computer nodes, that are connected via IP network and that are purposed to execute the common goal, to execute some common task. Why do we have several nodes? In case one node fails, your software will fail over to another node. For example, node 8 died, and everything will be started on other nodes. This way, your downtime will be much shorter. Oh. Okay. What is a cluster manager? Let's say we have a cluster of 2 nodes. Why 2 nodes? On this example, I can tell about most of the use cases, and it's actually not the simplest one, because the simplest is 3 nodes. So we will take as an example the 2-node system. Let's say we have two nodes running Linux, and we want to start some web server on them. And this web server to work requires, for example, authentication. So we need to start LDAP before that. And also it requires some business logic that needs data from database. So we first start database, then business logic, then web server. It also needs, for example, some decision maker, and it also needs some data from database. So we have all these processes running, and cluster manager is something that orchestrates the process of starting these resources, migrating them between nodes, and maintaining the dependencies between these components. What is Pacemaker? Pacemaker is a cluster manager. It operates in terms of nodes, which are Linux computer nodes, or virtual machines, laptops, servers, whatever, and resources. In Pacemaker terms, resource consists of 2 parts. It's the code. It's actually the executable that will be started, stopped on the system, and the configuration that is located in cluster database, or ZIP, which is not Postgres or MySQL or anything. It's specifically implemented in Pacemaker. So the goal of Pacemaker is to take the resources and to start them on the nodes we have according to the configuration in the database. Now I'll talk about more what is a resource like in Pacemaker. First we have the code, or resource agent as it's called. It should implement the following actions: start, stop, monitor, reload, and metadata. It can be implemented basically on any language. It should just be possible to run this implementation with those parameters and get expected exit codes. So you can run it on, write it on whatever you want. Start describes how resource is started. Stop, how it should be correctly stopped. Monitor is something that checks current status of the resource to make sure it's still healthy, that it doesn't need migrating, restarting, etc. Reload is optional. If it's not defined, Pacemaker will just call stop and start. And metadata is just some specific default parameters that should be returned for each resource. The workflow of the resource works this way. First, a monitor will be called. First, the monitor is called, not the start, to make sure that we don't have the situation when Pacemaker has failed with some resources started, it didn't manage to stop them, then it started again and tries to restart the already started resources. So we just call the monitor and expect that it will says that resource is not running. Then start is called, then Pacemaker will constantly monitor the resource to make sure it's still alive. And if something happens in the cluster or if user asks to, the resource will be stopped. The resource configuration can basically be divided into 3 parts. First part is parameters. The second part are dependencies between the resources. It's, for example, the database and the business logic. And the rules. The rules are also the dependencies, but it's not the dependencies between different resources. It's dependencies between the resource and some external factors. For example, some resource only wants to live on one node. Parameters can be timeouts. Each action in Pacemaker should be completed in a limited amount of time. So for every action, you should define a timeout. Restarts allowed. So Pacemaker, in case of resource fails, tries to restart it on the same node. When the number of restarts reaches this number, the resource will be migrated to another node in the cluster. Also, you can set some user parameters for the resource if it is needed. The dependencies can be of 2 types. First is order. It's when the resource starts. For example, we first need A, then B and C that can be started in parallel, then D. I only talk about the start order because Pacemaker does stops backwards. For example, if we restart B, first D will be stopped, then B will be stopped, then B will be started, and D will be started. So stop always goes backwards. The second type of dependencies is collocation. It's where the resource lives. So we can want to live on the same node with some other resource, or avoid some resource and only live on another node. The rules are basically, as I said, can depend on the node name or some other parameter. As a use case, we can have some nodes that are not exactly similar. For example, if only one node connected to some specific hardware, and this resource needs to be located locally to this hardware. So in this case, we will define a rule that will tie this resource to this node. Pacemaker handles fail handling. There are 3 types of failures for the resource: monitor, stop, and stop. If a monitor fails, the fail counter for the resource that is counted for each resource on each node is increased by 1. If start fails, the fail counter becomes infinity. And if stop fails, it's considered a system crash. Why is that? Because when you stop the resource and stop is not has not returned with OK exit code, you never know in which state the system is. Because, for example, if you stopped the database and you didn't manage it correctly, and if you try to start it anywhere else, there might be some data corruption, some race conditions, etc. So in case of stop fails, the reaction of Pacemaker will be to reboot the node where the resource was located. In this case, we consider that resource was stopped because the node was rebooted, and we can start it on some other node. In case of monitor and start failures, there can be 3 reactions. First, we will try to restart the resource on the same node. If we reach the threshold, we will migrate it to some other node. And if the threshold has been reached on all the nodes, the resource will be stopped on the cluster and won't start again until you clear the fail counters. There is some additional fail handling mechanism in Pacemaker, which is called Stoney. It stands for shoot the other node in the head. And it's actually the part of Pacemaker that handles rebooting these nodes. Why do we need to reboot some nodes? Let's say we have 2-node cluster and it has a network between the nodes, and this network got broken. What will we get? The first node will think it's alone in the cluster, and it will start all the resources like it's alone. The second node will also think it's alone in the cluster and also try to start every resource available. Not all resources are implemented in that way that they can live in several instances in the cluster. So it won't be pretty, like if 2 girls came into a party in the same dress, just because the resources are not implemented in the way that they can live in the same time in several places. Stoney mechanisms protects us from such situations by rebooting one of the nodes that lost connection. The Stoney is called on the node start to make sure we have consistent cluster situation. When the node is lost, to make sure it's actually rebooted or gone from the cluster and not tries to start the resources and the network is lost. And when a stop of the resource has failed, to execute the node reboot. How Stoney is usually implemented? The actual implementation lies on the user because it highly depends on the environment of which your cluster consists of. First, and the most common way, is to have the second network. So if you have one network that Pacemaker communicates with and it's get broken, then your implementation of Stoney can check via second network if the second node is actually dead or if just the first network connection broke. In this case, you will be able to fence the second node to reboot it forcefully to avoid the split brain situation when both nodes consider them a single node in the cluster. The second type of the Stoney implementations can be via shared storage, when 2 nodes communicate not via the network but via storage. In this case, developer will need some additional mechanism to be able to fence the second node through this storage, because it's quite easy to check that second node is alive if it writes something constantly to the storage. It's not that easy to reboot it via storage. Third case can be if, for example, your cluster is the several VMs that are running in vSphere. In that case, you might use the vSphere API to check if the other VMs are still alive. So if everything is implemented correctly, there shouldn't be the case when both nodes try to reboot each other, because the decision-making mechanism should do it that way that only one node will be rebooted. Otherwise, the DU time will be increased. Very briefly about how it looks like from the Pacemaker architecture. On each Linux node in your cluster, the following number of processes will be started. The cluster abstraction layer, it's not a separate component. It can be actually several mechanisms. Currently, I think only OpenACE and CoreSync are supported. CoreSync is the most common one. It's a separate open source project. And it implements all the messaging between the nodes. It reports when a node came, when a node left, and it passes the messages between the nodes. The cluster resource management daemon is the orchestration component that makes all the decisions, passes them to the other nodes, passes them to the other processes of the pacemaker. Cluster information base is the database where the configuration is stored. Policy engine is something that gets the configuration and actually calculates the resulting scheme where the resource should be started, in which order they should be started. The local resource management daemon actually executes the start-stop monitor actions when cluster resource management daemon commands it. And Stoney daemon is something that calls the Stoney implementation in, when it's needed to reboot the second node. That's for the overview of the pacemaker. Now let's go to what issues we have encountered when working with it. Generally, it's a very stable system. It works fine, and in the last years it has improved significantly, but we still have some things we should work with. First is performance adjustments. Pacemaker tries to help you by balancing the load on the nodes, and it doesn't allow to start more than n resources in parallel. The calculations on how many resources can be started are done based on only one parameter, load average. Who knows what load average is? Okay. For those who don't, it's the number of processes that are currently waiting to be executed. And on our system, it's like this. Don't be surprised, I'll talk about it a bit later. Pacemaker uses the following formula to calculate how many resources can be actually started. It divides load average by the number of cores, multiplied by the load threshold value. It actually can be set in the configuration of the cluster, so you can adjust it as you want. So this formula calculates the limit, and if it's less than 1.6, don't ask me why this number is just from novel information. It's considered a normal load. Then, as many resources as you want, you can start in parallel. If it's more than 1.6 but less than 2, it's medium load, only 2 resources will be started in parallel. If the limit is more than 2, only 1 resource on each node. For our system, so by default, you have load threshold at 80% in pacemaker configuration, which should mean that you shouldn't load your system more than 80%, whatever that means. We have 2 cores. We have, as I said, load average about 40. For us, limit is 25, which is much, much, much larger than 2. Why is that? You might think that we have high CPU load. We don't. We have 90% CPU idle all the time. Why is that? We have a lot of processes in the uninterruptible sleeps. It's not that unusual for a lot of types of systems when some processes are waiting for the I/O, for the network, for the disk. And in this case, Pacemaker always thinks that you have highly loaded system, but you don't. You can start resources in parallel in this case. So what we did, we just increased the load threshold to 8,000% to adjust the numbers so they fit us. But unfortunately, this mechanism is not ideal, and it should be improved. The second issue we've encountered are upgrades. If you have some software that is a resource, you will probably improve it at some point and want to install the new RPM on your cluster. Pacemaker doesn't have resource versioning. So you have some configuration and you have some code located on each node, but they are not versioned. So a lot of issues come with that, because if you try to upgrade it node by node, then you will have a case when you've installed new code, but there is still old config in the cluster, or you have old code, but you already updated the config. So what you have to do to upgrade a resource in Pacemaker, you need to stop your resource on all the nodes, upgrade new code, upgrade the configuration, then start the resource. It takes additional time, so your resource is down for longer time, so your end user doesn't have the functionality it provides. Also, Pacemaker doesn't have the point of time when you can check that upgrade has occurred. So it starts, before it starts, you can't check the database because you don't have access to it. After it starts starting the resource right away. There is no point of time where you can check that upgrade has occurred. For us, it's very important because we upgrade our systems via reboot of the node. So what we've done, we've added resource versioning via user attributes for the nodes, and we've added specific resource to delay the start of the resources. How does it look like? For the versioning, we now have not only resource configuration in the database, we also have version parameters on each node that define which code version is installed for each resource. And in the database, we have the rules that define which version should run, because this version is the version of the configuration in the database. So when you upgrade something, you upgrade the version of the resource of the node. For example, here we have resource 1 updated. Then you update the configuration with the rules, and resource simply migrates to the node B. And after that, you can install it on node A. In this case, you have less downtime of the resource. You don't depend on how long the resource is actually installed. We've also added anchor resource to check for the upgrades, to make sure we have the time to update everything in the database. And we've made it that all resources depend on this resource. It doesn't look pretty, but it's the only way in Pacemaker to actually check that something had happened when it starts. Also, Pacemaker is it's quite user-friendly to be configured, unless you want to do it automatically, because it's very user-oriented. You can configure a resource by adding a resource agent, doing 3 interactive, very pretty calls with help and everything. 3 calls for the action, start, stop, monitor. Average, you have to put about 3 parameters in, at least 1 dependency in our case, or even more if resource has any actual dependencies, and at least 1 rule in our case, also more if it needs it. So minimum 8 calls per resource. You can also do it in a bench via XML config that is not validated. So if you have made a mistake, the result won't be, it will be unexpectable. And it takes about 2,500 lines of XML to describe 38 resources. So it's a lot of writing. 1,000 lines of plain text config, also not very convenient. What we did was we've written a lot of scripts that we've created an XML for each resource. It's very simple. It's validated. It gets parsed, and the config is generated, including all our specific rules for the versions, the dependencies from the anchor resource at all. And we handle upgrade correctly. And we get all these XMLs and parse them and have Pacemaker config as the output. That is put in the Pacemaker, and we have everything under control. To do that, we use Pacemaker external interfaces to check for the versions to upload new configs. Pacemaker has 2 types of UI. First is CRM. It's very, very slow. It's interactive. It asks a lot of questions, and not all of the options have force option. It's very reliable, like a brick, so it almost never fails. It's async, but even though it's async, it's very slow. 1 call takes 1/3 of a second. The second interface is sysadmin. It's very fast. It's very unreliable. It's 20 times faster than CRM, but you might get 19 calls successful very fast. 20th will fail in 10 seconds, which is not good. It's also based on XPath, so learning curve is required if you don't know it. But it's very flexible, and sometimes you can do what you can do by 20 calls of CRM via one call of sysadmin. So I've discussed upgrade, automatic configuration that we've solved via some additional scripting and additional resources, and the performance. The problem here is that with all our scripts, because the Pacemaker interfaces are so slow, if they're reliable, it takes 30 to 40 seconds to upload our 30 resources. It's terrible, I know. Currently, Linux starts in 5 seconds. Pacemaker starts in 5 seconds by itself. So we have a lot of CRM calls. So this is something that has to be solved. We need to shrink that boot time. The true solution would be to fix the Pacemaker. And we've actually started doing this. This year, we've opened a project with the university to contribute to open source. We've already added the version parameters and dependencies. This way, user can set the different parameters for the different versions of the code. And on one node, the resource will be started with one parameters, and if it migrates to the other node, with another parameters. So it's a great improvement for us, and we can reduce our number of calls twice, so twice reduce of boot time. And actually, these changes have been included in the release candidate 1.1.16. Hopefully, they will be released in about 2 months. We've also added option to start Pacemaker in standby mode when you can check the database, the content of the database, so get all the configs, but the resources are not yet being started, so we won't need the anchor resource anymore, so less configuration, less dependencies, faster boot time. So what's next? As I told, load calculations can be improved by a lot. Rules versioning wasn't implemented. File handling can be improved by a lot. So we are going to continue our contributions to Pacemaker. Feel free to join us in using and contributing to the Pacemaker. It's a great product, and it gets improved all the time. So thank you, and if you have any questions.
Thank you, Victoria, for this excellent presentation. So time for questions. Okay, I see.
Hello. Hello.
Hey.
Thank you. I have a question. What about database? What about situation when you have two databases on node 1 and node 2, and you have failed node 1, then you have master at node 2, and then node 1 up again. Recovered.
Okay. Pacemaker is a cluster manager. It doesn't really care what the resource is. So if you mean the Pacemaker database, or if database is a resource?
I mean if database is a resource.
Database
You
is
have
a
web
resource.
server.
Okay. In that case, it all depends on the implementation of the resource itself. So if it uses shared storage, it shouldn't be a problem. If it doesn't use shared storage, then it's all the question on how the information gets to the second node in the first place.
That's my question.
Yeah, unfortunately, Pacemaker is not giving any restrictions on what the resources are. So it's on the developer to implement the resource.
Okay, so you are not using databases with Pacemaker, or you are not solving this issue? Or
We, in our case, we use a database with Pacemaker, and it's located on the shared storage.
Okay.
In this case, we don't have this issue.
Thank you. Next question. Okay.
Hello.
Okay.
So you've talked about Pacemaker, and do you know maybe other cluster orchestration managers? Do they have the similar bad sides, cons?
Yeah, I didn't talk about that. Yeah. If you talk about other cluster managers, there are actually two types. the container cluster managers, which is a bit different talk because we are talking about Linux processes here. You don't have to create a Docker container if your system for some reason cannot run in a Docker container. This is your case. For the Linux processes, there are no other open source cluster managers. So no, they don't have these downsides. There aren't any cluster managers.
Еще вопросы?
Can you talk more specifically what's wrong with fail handling?
With fail handling, basically we don't like that when resource has failed on all the nodes to the threshold, it's stopped and nothing is being done. Because a lot of the times developers can create recovery methods, and in Pacemaker there is no way to run them. So we want to add some additional option to run the recovery in case it's possible, in case the developer has defined it.
Thank you. One more question.
Hi, thanks for a great talk, firstly.
Thank you.
Second thing, I think this all concerns to active-passive things, right? So not really active and distributed.
Pacemaker doesn't care. It has both configuration. On the Cluster Lab side, that is actually the Pacemakers website, you can find the examples of active-active, active-passive configurations. It also runs, my examples were on 2 nodes, because it's shorter to talk about, easier to imagine, and it covers all the use cases, but it can be run on a lot of nodes. I know we've run up to 10 or 20 nodes, I think, in our testing.
Okay, thank you. One more. There was no question anymore?
On the back of the room.
Okay.
Thank you. What is, how much is average downtime when, if cluster master node fails,
Okay.
and the slave become active?
Okay. Pacemaker, this actually depends on the timeouts you set, because you can configure the time for each token, each message, that the timeout for each token. So Pacemaker won't consider the second node failed until this time has passed. If a node fails, this token will pass, and it will leave another token to renegotiate if the network will magically appear again, if it was just because of the latency issues. And then it will be, the delay will be about 1-2 seconds, so it's very, very fast. Usually, because people leave 5-10 seconds to renegotiate the cluster, the time for the Pacemaker logic to fail over is being lost on the amount of time we wait for the renegotiation.
Okay, thank you. It's one more.
По-русски можно? Pacemaker его можно использовать для распределенной сборки? Можно его использовать? Нет? Как бы у вас, может, примеры есть какие-то?
Мы не использовали. Okay, I'll translate the question and the answer. So the question was if we can use Pacemaker for distributed build systems. The answer is we haven't done it. It's possible if you run resource that does the build.
Okay, thank you. Other questions? Okay. What? Okay, Sim.
Is Pacemaker somehow related with the management of the shared storage, or what is used for manage it, the shared storage in the cluster?
Pacemaker, the Pacemaker itself is not related to the shared storage topic. It's our specific implementation of the system we have. that it has shared storage. Pacemaker can work without it if it.
Thank you.
Okay.
Okay, and more questions? Okay.
Have you been using CoreSync extension, CoreSync void quorum for mathematical recalculate of quorum in case of some nodes is failover?
Okay, CoreSync implements totem single ring protocol to renegotiate after the node has been lost. That's basically all I know about how it does the renegotiation. Yeah. Okay. Okay. CoreSync. The CoreSync that is being used with the Pacemaker has the extension that recalculates the quorum after some node has been lost. Yes. So it's working.
Okay, thank you once again. And next question.
Any?
Probably the last one. Okay, so thank you very much, Victoria, for your nice presentation.
Thank you for staying so late.
Yes, thank you for sitting so late. Please.